We are here to showcase what the art of possibility is. We are going to talk about observability and alerting ecosystem that we have built inside Snowflake. And it has the AI flavor to it. It has the PagerDuty component, which is actually a rota tool, as we call it in our lingo, right? Who we are, right? We are Snowflake Data Platform Team. It means that we are that data team who you are in your organization in many ways. We are internal data team, and that's where we call this session as Snowflake on Snowflake. That is, we as a team utilize all the capabilities of Snowflake to solve our own problem. And that is what we are going to demo today. Okay, I hope everyone is excited about this. Let's go to the next slide. Just as an introduction, my name is Abhishek. I'm Senior Manager Data Engineering at Snowflake. I have here with me Sudhir. He is manager, and between us, we have nearly 25 years of experience in data domain. And we are actually here to talk about what our team have built, which is a very strong data product, as we call it, which we internally use it. So we're going to talk about the problem statement, which is very generic, which I think everyone will have faced in their data journey. We are going to talk about a solution, architecture, and how AI is helping us to achieve what we want to achieve. And then there will be a demo where we are going to show you of what we were able to achieve and a very close to of the ecosystems that you all will remember or identify with. So if we can go to the next slide, Sudhir. We are going to talk about the problem statement. All the data engineers or all the fellows want to work on exciting stuff, which is creating awesome pipelines with everything which is observability intact. But then we spend nearly 20% of our time in doing operational and maintenance overhead. Is it not a correct statement? We need to go back, we need to fix if something changes, if something bad, or if something which is not working. And as and when the enterprise grow, this becomes overhead for us as a data team. And that is what we want to solve. There are three aspects to it: volume, accountability, and effort. If same kind of pipelines are failing again and again, it becomes an alert noise. Do we really need to fix everything? Maybe not, but we'll not know if the volume is high. Where to go, what to fix if you are new into the team, or if you are not new, but then you have so many ecosystems to go and fix, you will not even know how to do that. And that's where accountability comes into picture. And of course, if you're doing the same activity again and again, fixing again and again, working on operational stuff, it becomes an effort issue in many ways. It becomes a challenge, and are we learning enough is a question again for the team. Just to set the context, we have nearly 2K of the pipeline inside Snowflake. We ingest data from 240 application, as we call it. There are 20 plus domains that we serve for Snowflake. And then there are 400 warehouses that basically we support onto. Thus, our ecosystem is quite big. And you can imagine 2,000 pipelines in a day is a huge number. And that is a problem statement that we were facing, and we resolve it using Snowflake only. So if we can go to the next slide. All the three of the problem that I talked about can be resolved if we bring everything at one place, which is the console, as we call it, is what the proposed solution to that. We, by bringing the data at one place, were able to actually see and analyze the incidents faster and really work on the things which really matters for us. The resolution was faster because it was proposed by our AI solution of where and what to be fixed exactly, in spite of referring to many places. And of course, it has added a lot of productivity, and those will be very visible when we go to demo. So we go to the architecture, and this is where the next of 5 minutes is where I'm going to spend time. And this is an important slide where how we have resolved this problem by using Snowflake tech stack. Now, if you can relate, right, we don't bring data inside Snowflake by using native capability of Snowflake, but we have many other data set where we need to build custom connectors. So you have data coming from custom ingest. You, of course, have Snowpipe, but then you have replicators like Fivetran. There are warehouse logs that you might need to check. And then, of course, Airflow always have been there, right? With these, there comes a lot of data inside Snowflake. What we did, we took the logs from each of these ecosystems, added that with our own PagerDuty that we use for anyone who is on call or receiving critical alerts, and created a ML model which was actually analyzing which job is critical and which is not. Now, let me double click on that particular place, which is critical data pipeline references. This is actually a ML model built inside Snowflake, which was working on the features of who is using the data, that is persona, what is the usage of that particular data pipeline or the data that we are ingesting, and based on those features the criticality was defined, so it was not manual. Now it is important to understand what a person feels a data job to be manual may not be true, and that's where we need to add those ML models to actually do the job for us, and that can be done inside Snowflake, as you know, using Snowpark capabilities where you can run ML, right? Now once you actually plan for everything to be brought inside Snowflake and then have a model which predicts for you what is critical and what is not, that's where you create and build one place shop, and as we call it, platform observability app. It is a Streamlit app which is again inside Snowflake. So what Sudhir is going to show you is a SIS app, the Streamlit inside Snowflake, which again is bringing all the information but all the actionable also on the console. And what is the result outcome? The result outcome is awesome. We are not only summarizing what has failed and creating those summaries perfectly well, but then we are also creating recommendation which Cortex is generating. In many ways, we are creating those recommendation statements from our application itself, which any analyst can go analyze and fix a job. Moreover, through our external features, we can actually take a lot of actions. So between PagerDuty or between Fivetran, Airflow, or any places where we want to fix a job or take any necessary action, we can do it through the console itself. And that is the beauty of that particular console. So just to summarize, right, what we have done is first to bring all the data at one place. It means that now analysts need not to go through many hassles, going through many interfaces to look into data pipelines. Secondly, we have made sure that we are using a ML program to define the criticality for us. Thirdly, we are making sure that it is a recommendation which is coming thus. We can shift the job that we are doing to someone who is L1 or service desk support if they can actually go through the recommendation correctly what we have fixed. And that is the power of Snowflake, and everything that you see here is actually blue. It means everything is inside Snowflake through that particular one UI. Now, we are very proudly saying that, and it is something which is a practitioner to practitioner connect, because we feel that the main power of Snowflake is doing everything inside one UI, and that is what Sudhir is going to demo today.
So hello everyone, as Abhishek mentioned that we have built this fantastic app which consolidates all the modalities using people ingest data into Snowflake. And we have built this Streamlit app. It is, as you can see, it's inside Snowflake, app.snowflake.com. So this is a demo version. It does not actually replicates what we have in production, but it has everything that I wanted to show you guys. So let's start the demo where you can see there are two tabs here. One is ingestion monitoring and ingestion observability. Ingestion monitoring is for the people who are on the rota and monitor all the data pipelines that are running on daily basis. They can look into the failures, take some actions, acknowledge, resolve all the PagerDuty incidents that they are getting on their mobiles, right? So this tab is for that. The second one is ingestion observability. First of all, we'll see ingestion monitoring, which is currently open, and then we'll go to observability and then again come back to monitoring for the AI feature. So if you see the first thing that Abhishek mentioned, like where we defined the criticality of all the jobs that are running inside our platform, right? Now, how do we do that, right? There are two types of things where we consider a business persona, where a business says that I have a critical downstream job, which is dependent on this ingestion job, right? Now, that is one persona, and second is who is using it and what is the downstream usage. If you have critical workloads that are powered by your data pipeline, that becomes critical for us, right? How do you know that? We use Snowflake account usage to run our AI model on top of it, like who is using our data, what is the account usage, who is querying it, how much queries are daily getting fired on our data sets. Depending on, we defined the criticality of the job. So we defined two criticalities. One is non-critical and another is critical. For critical ones, you'll get PagerDuty calls on your mobiles. For non-critical, you'll see in the grid, which is just below here. So that is how we define the criticality. If you click on this view data, you'll see all the critical jobs that are getting failed today and non-critical jobs. So on the right hand side, you'll also see the person who are currently on call. So this console, a Streamlit app inside Snowflake, it talks to PagerDuty. You don't have to go actually inside PagerDuty to take the actions. You can take all the actions that are already available in PagerDuty from this console. You can see the person currently on call and who's going to be the next on call person, and the people who on the rota, they can use this button to see, let's say we want to check what are the critical failures, right? You can see there are 3 critical failures where we can see the job details, like what is the job name, what is the source, right? This is custom ingestion, which is coming data from different connectors. We have Fivetran, which is a third-party tool, and it replicates data from different sources into Snowflake. Then you can also see who has acknowledged it, right? If a pipeline fails, usually the question comes, who is looking into it, right? What is the current status of your failure, right? You might get this question in your team. So by just looking at this grid, people will understand who is currently looking into the pillar, because the person on the rota has to acknowledge the failure. After acknowledging, he'll take some actions, right? So let's see what are those actions. So if you go here, you can have different actions. Like first thing you need to acknowledge. Then if you are working on it, you are trying to resolve the failure, you can mark it in progress. If there is a cross-team dependency, right? If your job failed, let's say it has a credentials to connect to, let's say Microsoft Azure, or let's say it is connected to AWS billing, and the credentials are expired due to some reasons, or there are some issues with the credential. So you will have dependency on third-party team, right? You won't be able to resolve it on your own. So you can mark it as cross-team dependency so that people will get visibility, like this is not currently, the current action item is not onto you, but there is a cross-team dependency here. And then you can also rerun the jobs here. So this is not just a dashboard. You can take actions using this dashboard. So if you select this job here and click on this rerun button, right? There is a rerun button on the right hand corner. Then it will actually go and it will rerun the job. It's not only Snowflake task. It can rerun Airflow jobs. It can rerun Fivetran connectors. It can rerun Snowflake task as well as, and it can also try to do like manual Snowpipe run. So all of that can be done by using this one. And the last one is, let's say you have written your job in a way that it is idempotent, and you know that by the time my next run happens, I don't need to worry about my previous failure. So if your jobs are idempotent, the next run will automatically take care of my previous failure. So you can just ignore the task. And whatever actions that you have taken till now, if you are able to resolve the job, you can just mark it as resolved. As soon as you mark it resolved, what it does is it goes into PagerDuty. It already knows what is the incident that is being created for this job failure, right? So you don't have to log in into PagerDuty and then resolve the incident. Also for monitoring, this is the only grid that you need to worry about, right? The summarization that Abhishek talked about and the classification of jobs, right? Both of the things are shown here. You will get all the details of the job here only. After you resolve the incident, right, the job will disappear from this grid as well as from your PagerDuty, because you don't need any further actions on top of it, right? So it's a two-way communication between Snowflake and PagerDuty, right? So if somebody wants to drill down at application level, there are some filters that we have given here. Let's say you want to check what is happening with Fivetran or Airflow or Snowpipe, you can also do that. If you want to filter out like who is working on which problem, right? If you have multi-people team, then you will want to understand, let's say, like what is my developer is doing, right? You can filter by, acknowledge by, and there is also a status filter, right? You will see the status here as well. Whatever is the person on the rota has taken action, then there will be an error message. We'll come to the job details. I just wanted to show you guys the data observability feature that we have. So let's go to ingestion observability. So as I already mentioned that we ingest data from multiple modalities using multiple features like Airflow, then Fivetran, Snowpipes, right? Now, if we want to know at single point in time, what is the health of my data ingestion, right? So this is a heat map that we have created. We ingest data from around 240 sources into our production database. And this heat map gives us bird's eye view of what is happening into our ecosystem. As you can see, the darker the color is more the failures. So currently warehouse management jobs are failing more. Then let's remove the application. Let's say I remove the warehouse management, you will get the second most one which is failing. Let's say sensitive one. So these are all the applications from which we ingest data into our ecosystem, and this single view provides you a heat map of everything, like what is happening into ecosystem. Now, after this, let's say you want to drill down. Let's say you want to understand what is happening with GitHub, right? You can go down and we have a failure trend. Before that, I'll go to application details and I can just search, let's say, GitHub here, and the diagram and everything will get refreshed. So you can see out of we have GitHub and 117 tables are getting populated for GitHub. Out of those, 96% jobs were succeeded, which are populating these 117 tables, and then there are 4.05% jobs which have failed, right? Now, whatever we ingest, right, we already told you that we define the category based on the usage of the data, right? So we do monitor if I'm ingesting 100 tables for a source application, whether the downstream is actually using those 100 tables, right? Because it's unnecessary overhead for the data team to manage those 100 jobs. If people are not using it, we would want to decommission it, right? So this usage matrix here, right? It tells you what is the percentage of tables that is being used, then also the freshness of those tables. So out of 117, as you can see, 102 are like fresh tables, and those are the ones getting used. So the remaining 15 tables, we might be ingesting, but nobody is using downstream, right? So there is no point of maintaining those 15 pipelines. You can go ahead and decommission those. Then you have some graphs, like you can see the daily failures over time. And if for these 4% failures, right, people might be taking some actions like manual reruns and everything. So you would want to monitor that. So the graphs below, it shows you what is the manual run stats. Even after manual run, whether it was succeeded or failure, right, you want to monitor that. So as you can see, we deployed this application inside our Snowflake platform team around October. We used to get like 1200, 1300, like thousands of failures per month. And now, as you can see, we are in June and it came to like 2-digit. So that is what the impact we were able to generate by having this app into our production environment. So the last thing that I wanted to show you guys is the Cortex functionality, the AI functionality, where let's check this failure, zoom. If I click on here and then click this button, see job details, right? So this is a customization. It is ingesting data using Snowpark external access, and it directly connects to Zoom API. It fetches the data and push into raw tables inside Snowflake. Now, if you go down, you'll see what is the task name, what was the query ID for this run, and what was the error that came when this failure happened. So these are the last 7 runs. If some developer has fixed this beforehand, then what was the fix? Like, we can put comments here, then you'll see the definition, and this is the Cortex recommendation. So this is the AI part where we are using Mistral model inside Snowflake Cortex, and it actually goes and checks what is the failure. We are feeding all the failure data to Snowflake Cortex, and it is generating recommendations for us, right? So as you can see, this one is 429 error, where we have exceeded the retry timeouts. There is an API rate limit for most of the APIs, and we have been retrying multiple times, so that is why the error. So you have to limit the number of API calls while you connect to such kind of sources, right? So this is what the error, and if you go by the recommendations that Snowflake Cortex is providing, it will mention what is the error, how you should fix it, plus it will also try to provide you a sample code which will help you to actually go and fix the job. So as you can see, this is the code here that is getting generated by Snowflake Cortex. So a developer can look at this and he will get a very good idea of what is happening with my job, how to fix it, what are the possible ways to fix it, and also some help with this code, right? So he'll go back and try to fix, and then he'll try to resolve this job from here. Like, he can put the select here and then he can put resolve. So yeah, I think that's all I wanted to cover. Let's go back to presentation, and I hand it over to Abhishek for the conclusion.
Sure, thank you, Sudhir. So, I mean, what is the takeaway from this, right? I mean, of course, we looked into what Cortex as a functionality providing us, how beautiful it is to build an app inside Snowflake. But the primary theme of not moving the data to the app, but then bringing apps to data is what we want to call it out. Once you ingest all the logs, and it is near to real time of that ingestion that you're doing, it's art of possibility that we have showcased, where through one UI, through that interface, a complex problem of data operation we have minimized to at its strength. where we now can summarize everything at one place. Cortex is giving you that particular code to go and fix. And I'm challenging Sudhir and everyone in my team to actually create auto heal's job in spite of only monitoring. Can we go and take a step beyond of auto healing as well? But then that being said, the power of platform or the possibility of platform exists. This is just the glimpse of what you can go back and do once you have Snowflake in your premise to not only practice Snowflake from analytics capability, which is awesome, but then also use Streamlit, also use Cortex functionality to build applications like these in your ecosystem, beat whatever problem statement that you are facing, is what the mindset that we are talking about. Thank you so much for your time, guys. Thank you.
Thank you, guys.